All right, so we're on question 4 from 1998 in the BC FRQ. We've got a differential equation given by xy over 2. On the axis below, we need to sketch a slope field for the differential equation. When we're at the point -1, 3, what should my slope look like? Starting with Kyle.
It will look, I guess. I would point out. Sorry, the third point, the 1 and 3.
So -1, nope, not writing. -1, 3 is this point here. What should the slope look like?
Oh, negative. A negative slope, negative 1 over 3, negative 1 over 4.
Our slope is xy over 2.
Mm-hmm.
So what would our slope be equal to here?
Negative 3. Negative 3 over 2.
-3 over 2. Okay, so starting from this point, if I went down 3 and over 2, I would be pointed towards this point. So that's my slope. Let's go ahead and finish off the rest of these. So I'm going to have you do all the -1s. I'll jump to Eric for the 0s and positive ones. So -1, 2, what will my slope look like?
2 would be just 1. The slope of 1 and
Okay,
negative 1. No, wait, negative 2. So negative 1. The slope is negative 1.
Mm-hmm.
And on 1, it would be negative 1 over 2.
-1/2, okay. Alright, Eric, over to you. When x is 0, what's going to happen to our slopes?
You'll all equal to 0.
They will all be equal to 0. Okay, so that's horizontal lines for all of 3 of these points. What about 1 and 3?
Three over 2.
Okay, positive 3 over 2, so something like this. Whoa. Okay, 1, 2.
Positive 1. Positive 1.
Okay. So we get a slope field that looks something like this. Okay, so on the real AP exam, the way that they're going to grade this is they're going to look for, does our slope slowly get more and more steeper as we go? And then is it positive or negative? So my slopes are getting more and more steep as I go up. All of my slopes are 0 where they're supposed to be 0, and they're positive where they should be positive and negative where they should be negative. It's not, they're not actually going to check your line and follow through and see if you're actually down 3 over 2 or whatever. Okay, for part B, I want, if we have a particular solution to a differential equation where x is 0 and y is 3, and Euler method starts at x equals 0 with a step size of 0.1, I want to approximate 0.2 and then show the work that leads to our answer. Do either of you remember Euler's method?
Y new is equal to y previous plus delta x dy over dx.
Awesome. Okay, so from our start point at x equals 0, what's our y previous?
3.
Okay, our y previous would be 3. I think I need to move this keyboard. Okay, our y previous would be 3. What's our change in x?
0.1.
0.1, and our slope.
Yeah, xy over 2.
Okay, what's our x, what's our y?
And in this case, 0 and 3.
0 and 3, so this is 0, 3 over 2. Should be equal to our new y value. Okay, so what's our new y value?
3.
Okay, so y at 0.1 is 3. We can do another step size. So same formula over to Eric. If I want to find our y value at 0.2, what's going to happen?
3 plus 0.2 plus 0.1.
Okay, so my change in x would be from 0.1 to 0.2 is 0.1. Okay, and then I need my dy over dx.
3 times 0.1 over 2.
Looks good. Okay, so this is 0.1 times 0.1. So that's 3 over 200, I think, after I multiply this out. And this is 0.2 equals 3 plus 3 over 200. If I'm going to combine these, what am I going to end up with?
603 over 200.
603 over 200. Okay, that's good. And last one, part C. I want to find the particular solution to the given differential equation with the initial condition f0 equals 3. Our differential equation was xy over 2. So we have dy over dx equals xy over 2. And f at 0 is 3. Find f at 0.2. Okay, so for this differential equation, what's our first step? Eric.
Put x and x in one side and y in one side.
Perfect. So separating our variables, if we don't do that step, we actually lose all credit for the rest of the problem. So out of every step on the AP exam, that's the one that's worth the most amount of points, potentially. Okay, so as long as we've separated our variables, then we can earn more points for this problem based on our process. Okay, so all my y's are on one side, all my x's are on the other. Now what?
And integrate both sides.
Okay, I'm going to integrate both sides. If I integrate dy over y, what's going to happen?
ln and ln y.
Okay, so this is natural log of y is equal to
X over 2.
sorry, say one more time.
X over 2.
Not x over 2, no.
X squared over 4.
X squared over 4, perfect. Okay, and then I need a plus c for one of those, so I'm going to throw that on the right side since we're solving for y. Over to Kyle. What do I do next?
We solve for y, so we do natural log, the e of both sides.
Okay, raise both sides to a base of e, so that's e to the x squared over 4 plus c, which is all inside that power. And if I'm adding with the same base, what can I do?
You can multiply them to each other, so e x squared over 4 times e to the power of c.
Okay, e to the c times e to the x squared over 4. What is e to the c power?
Just e 0.
Not 0, but this is e raised to some constant, and that's still going to be some constant we don't know. So I can just rewrite that whole term as c.
Oh, okay.
X squared over 4. Okay, so now I've got a general solution that we can use. So in general, any equation that is in this form, once you derive it, will give you the derivative of xy over 2. I'm going to take this y value, I'm going to plug in our initial point, and we'll create a particular solution. So over to Eric, what's going to happen when we find our particular solution?
Do you mean what's C?
Yep, we need to solve for c.
C E log x is C equals C. C equals 3.
C equals 3, okay. So if c equals 3, then y is equal to 3e to the x squared over 4. And we need to find f at 0.2. So therefore, f at 0.2 should be equal to, I'm going to stick to Eric, because that was a fast one.
Y equals 3e 0.2 square over x.
Okay, so that's 1 over 5 squared divided by 4. Okay, what's 1 over 5 squared?
1 over 25.
Okay, so that's 1 over 25 divided by 4.
Four over 25.
Oh.
1 over 100.
1 over 100. So if I'm dividing by 4, that's the same thing as multiplying by 1/4. So that's 3e to the 1 over 100 power. And I think that's as much as I can do without a calculator. And actually check. Oh, this year everything was with a calculator, so I guess I would have just plugged that in and got a decimal answer. But if I was going to do this by hand, then I would have left those as fractions for both B and C. I'm going to go ahead and plug those in anyways, just so we can see how close we were. Kyle, if I wanted to find the error in part B, what would I need to do?
Graph both of them and see if they intersect or not.
Graph both and see if they intersect. I don't think that would give us the error. And error is how wrong our estimate was. So for B, we estimated. But for C, we did not estimate. We found a particular solution. So if I know the actual answer and I know the estimate, then how can I get the error?
Find y of 0.1 using the new equation and subtract 2 by 3.
Okay, you're right. So find our y value at 0.2, so the actual answer of 3e to the 1 over 100 power, and subtract our estimate that we had for 0.2 using Euler's method, which was 603 over 200. Save this as a value first. So our actual answer is A. Our estimate was 603 over 200. So if I do our actual answer minus our estimated value, we have an error of about 0.015. Okay, the question didn't actually ask for that, but because this is a little bit old, if I was writing this as a modern problem, I think I would add a question on error. Alright, let me zoom out before I go on. So, any questions on anything from number 4? Okay. I'm gonna pull up the scoring guide and we'll take a look at how we did really quick. Actually, I already have it up in front of me on the other screen if this doesn't load, but kind of wanted to show side by side so you guys can see what I'm scoring. Okay, I'll let that load in as we go. So there was 1 point for number 4 for having the line segments at all 9 points with negative, 0, or positive slope from left to right, and increasing steepness from bottom to top. Okay, so we do have increasing steepness from bottom to top and a negative, 0, positive slope for each line. So we get 1 point for that. For number 2, we have Euler's method equations or a table. We have an equation for that, so that's 1 point. 1 point for answer of 3.015, which was what we got here, I believe. 3.015, okay. For part C, 1 point for separating the variables. On the newer FRQs, there'll be a note here that says 0 out of 6 if not present. But 1 point for separating the variables, 1 point for the antiderivatives, that means our integral. ln y is 1/4 of x squared plus c. 1 point solving for y to get our general form. 1 point for solving for our constant of integration at any point, doesn't have to be at the end. And then 1 point for evaluating f of 0.2. Alright, jumping down. Check, make sure we haven't added anyone. I've got Andrew here. Hi, Andrew. Our temperature outside a house during a 24-hour period is given by this function, which is Fahrenheit at different hours. I want to sketch the graph for the Fahrenheit on the grid below. It's maybe a little bit difficult to do by voice. I'm going to graph just a couple points, I think, by voice. Andrew, are you there? Hi. That's all right. So right now, if I plug in t equals 0, what is f of t? Okay, if t is 0, then my cosine is 1, so this is 80 minus 10, which is 70. Let me change colors from yellow, because that's a little bit harder to see. So at 0, we're at 70. What about at 6? 80. Because this is easier to type, I'm going to have you finish this one off, I think. So can you give me 12, 18, and 24 as well? Okay, 90, 80, and 70. All right, and our cosine function is going to look something like this. So we've got our graph. For part B, I want to find the average temperature to the nearest degree Fahrenheit between T equals 6 and 14. So I'm going to zoom out just long enough that we can copy our equation. F of T is 80 minus 10 cosine of pi t over 12. Okay, I want average temperature between T equals 6 and T equals 14. Eric, what do I need to do?
Can you repeat the question?
Doing part B, I want the average temperature in the nearest degree Fahrenheit between T equals 6 and T equals 14.
1 over b minus a integral
Okay, you're right. What is B? What is A, though?
14 minus 6.
6 times the integral from
6 to 14.
6 to 14. Okay, I'm going to mark this as temperature average. Okay.
8, the equation 80 minus 10 cosine pi t over 12 dt.
Awesome. Okay, and this is still with the calculator, so I'm going to go ahead and plug that in. Oh, there we go. Okay, so I'm just going to type our formula in here, I think, so that we can use it later. I've got 80 minus 10 times the cosine of pi t over 12. Double check, we are in radians. And our average temperature, so 1 over 14 minus 6 times the integral of variables, y variables, function y1 in terms of x from our lower bound to our upper bound. That should give us our answer. Okay, so our average temperature was 87 degrees, because they asked us to the nearest degree Fahrenheit. Any questions on B? Okay.
No.
For C. Our air conditioner is cooling the house whenever the outside temperature was at or above 78 degrees Fahrenheit. I want to know what values of T was the air conditioner cooling the house. I'm actually trying to put that in here. So I want to know when this function was at or above 78 degrees Fahrenheit. What do I have to do? I think we're on Kyle.
We set up the equation where the 78 is equal to the function.
Okay. So I could say this temperature minus 78 should be greater than or equal to 0. And you're right, in our calculators we can set those equal to each other. So I'm going to do that, and then we'll calculate the intersect. That should tell us what time. So what do I need to write for y2?
78.
78. And then if I want to graph this, I want to make sure that I can see up to 78 on times that are between 0 and 24. So my x needs to go from 0 to 24. And my y value needs to go all the way up to, I'm going to match the window that they have here. So I'll go up to 100. And we'll graph that. Okay, so there's our bell curve that we have drawn here, and there's our line at 78. I'm going to calculate our intersects. So first curve, second curve, and our guess, I'm going to do my first one a little bit to the left. So we'll get our first point down here. Intersecting at 5.231. I don't know if we'll need that, but I'm going to go ahead and save that just in case I don't have to do that again. So right now, A is our first intersection point at 5.231. And we'll calculate another intersect. So first curve, second curve, but this time I'm going to guess over at, we'll do 18-ish, since I can see that's where we hit 80. And that should give us the right side intersect. So that's about 18.77. Okay. What are my units here? Hours. Go ahead and say degrees Fahrenheit since we've got people who use both metric and English here. Okay, for part D, the cost of cooling the house accumulates at a rate of 5 cents per hour for each degree that the temperature outside exceeds 78 degrees Fahrenheit. I want to know what the total cost to the nearest cent to cool the house was for the entire 24-hour period. So I need a cost equation first. It's Andrew's turn, but this is a hard one to write. So I'm going to skip over to Eric. What should our cost equation be?
Rate times integral.
Rate times integral, okay. So this is $5 per hour for each degree. So $5 per hour per degree. So our rate then, you said rate times integral, so that would be 5 cents times an integral. From what to what?
$5.231 to 18,770.
Okay, and what are we integrating?
the 80 minus 10 cosine pi t over 12 minus 78.
Awesome. I've got that extra minus 78 because we're only looking at how many degrees we are above 78. So when I integrate this, this is going to tell me the total accumulation of degrees that we had over that period. Then we'll multiply by 0.05, and that should leave us with total cost. So this equation is degrees, and then we integrate it in terms of times. That was degree hours. Dollars per hour per degree. And then we integrated, so as far as units go, that unit ended up being degree hours. So our degrees cancel, hours cancel, and we're left with dollars. Okay, so now I need to go in the calculator and actually figure out what this cost is. I check my y value right now. I am not subtracting by the 78, so I needed to throw that into my equation when I integrate this. This is 0.05 times math 9. I'm going to integrate variables, y variables, function. y1 is the 80 minus 10 cosine pi t over 12. I'm going to subtract the extra 78 there. We're going to integrate in terms of x from a to b, since we already have those endpoints stored in our calculator. That should give us a more exact answer than even what we wrote down here, which is 5.096. Andrew, I cannot have $5.09637. So what should I write instead if we're looking at total cost? Okay, round up the decimal to the nearest cent. So what should we write? $5.10. Perfect. All right. Let's see how we did. So we've got, first off, one graph, 1 point for a bell-shaped graph with a minimum at 70 and a maximum at 90, only at 12, minimums at 0.24. Okay, we look good. B, integral 1 point for the limits, and our 1 over 14 minus 6. Okay, 614. Okay, that was good. 1 point for the integrand of 80 minus 10 cosine pi t over 12. That was good as well. 1 point for answer of 87. 1 point for inequality of equation for part C. Okay, we've got that. And 1 point for solutions with an interval. I did not write my solutions in interval notation, so I think I would have lost that point. For what values of T was the air conditioner cooling the house? I just wrote the endpoints. Okay, so I want to convert this to an interval then, so RT needs to be between those two values. Okay, then for D we've got 1 point for our limits and multiplying by 0.05, and 1 point for our answer of $5.10. Okay, with that I think we finished all of the FRQs. Any questions from that one before we jump back to multiple choice? Right. Okay, so for the rest of these, we are allowed to use a graphing calculator starting with number 76. I want to know what integer would allow both of these to converge. I'm going to go integer again because this is an easier one to type. Let's take a look at the left side first. So, what values of k would allow the left side function to converge? Okay, k should be an odd number, so it will converge by alternating series. What about our right side then? K needs to be less than 4. Okay, so I need to be less than 4 and odd. So this one must be D. K must be odd. K is less than 4. Awesome. For 77, we've got this vector function where f of t is e to the negative t and cosine t. I want to know what the second derivative would be. Kyle, what's our first derivative?
Our first derivative would be negative e to the power of negative t and negative sine t.
Okay. And what's our second derivative? I'm going to stick with you because that was fast.
E to the power of negative t and negative cosine t.
Okay, so we just need to match. I've got E. Alright, going down to Eric. The radius of our circle is decreasing at a constant rate of 0.1 centimeter per second. In terms of the circumference, I want to know what the rate of change of the area of the circle would be. What did they give us first?
Constant rate decrease.
Constant rate of decrease. What's decreasing though? So this would be d something over dt, right?
dr.
Okay, the change in radius over time is 0.1 and it's a constant decrease, so this should be negative. Okay. Then I want the rate of change of the area in terms of the circumference. So what's our equation for the area of a circle?
2 pi r squared.
Pi r squared. Okay, circumference is the next thing we need, but circumference is 2 pi r. So if I want to find the rate of change of the area of the circle, then I'm looking for dA over dt. So what is dA over dt first?
2 pi r.
2 pi r times
Oh, dr over dt.
dr over dt with chain rule. If our circumference is 2 pi r, then I can substitute. So dA over dt is equal to our circumference times dr over dt. negative 0.1. So this one is B. All right. For 79, I want to know what positive values would allow f to be continuous for all real numbers. Okay, Andrew, it looks like we've only got a couple options, 1, 2, and 4, looking at our answer choices. So if I plug in x equals 1 right now, will this be continuous for all real numbers? Okay, you're right. However, actually, even the x minus 1 on bottom would still make this discontinuous as well. Because even if we have a removable discontinuity, that's still not continuous. So, you're right that 1 is not okay, and you're also right that x plus 1 would be a non-removable discontinuity or a vertical asymptote, but the x minus 1 is also not okay. So if you can give me a quick yes or no, is 2 okay for A? And what about 4? Okay, so they're all not okay. If I plug in 4, then the whole thing gets removed with the x squared minus 4, but a removable discontinuity is still not continuous. If I plug in 2, I'll have x minus root 2, x plus root 2 on bottom, which gives us 2 more non-removable discontinuities. So for this one, none of these values that we plug in for A would allow us to be continuous for all real numbers. Okay, for 80, I've got some region R that is enclosed by this graph, the x-axis, and x equals negative 2/3 to positive 2/3. I want to know what the closest integer approximation of the area would be. I do have a graphing calculator, so I forget who we're on. Eric, what do I need to do?
Get the intersection. Oh, sorry. Integral.
Okay.
Integral negative 2/3 to 2/3.
Okay, you're right. I'm going to write those up for my last part of this, though, because of the way the calculator works. What am I integrating?
1 plus natural log cosine 4th power x dx.
Natural log. Open, open, open. Close, close, close. Okay. So x from negative 2/3 to positive 2/3. Okay. So I've got 0.919. What's our closest integer approximation?
0.91.
1. Okay, I'm just going to write over here, we integrated y in terms of x from negative 2/3 to positive 2/3. Okay. Over to Kyle. I've got our derivative up here is the square root of 1 minus y squared. I want to know what the second derivative would be in terms of x.
Okay, so I simplified it into 1 minus y squared to the power of 1/2.
Okay. I'll write that down here, I guess. So still have not derived, but I can rewrite it like that. Okay.
And then I derive, so 1/2 times 1 minus y squared to the power of negative 1 over 2 times negative 2y dy over dx.
Awesome. Okay, now I need to go back and start substituting. So this 1/2 and this negative 2 can cancel and leave me with negative 1. So I'm left with negative 1 over, this is a negative exponent, so what can I do with this part?
Negative y? Sorry?
If I have a negative exponent, what happens?
Oh, it goes to the bottom.
Goes to the
So
bottom,
it's going to be negative 1 over square root of 1 minus y squared.
Great. Okay, on the bottom, because of the negative, a square root because of that fraction, so 1/2. I've also got a y that's left on top, so I'm going to throw that in there too. This will be negative y. And then I'm going to multiply by dy over dx. What is dy over dx?
Square root of 1 minus y squared.
Okay, so that's going to allow me to cancel. And I'm left with just negative y. Alright. For the next one, f of x is g of x plus 7 between 3 and 5. I want to know what the integral of f of x plus g of x would be from 3 to 5. I think if I was going to do this, I would rewrite this completely in terms of g of x. So Andrew, if I'm going to rewrite this completely in terms of g of x, this will become the integral of 3 to 5 of what? Two g of x plus 7. Awesome. Okay, you're right. I'm going to write it like this, though, just for everyone that comes afterwards. So this is like this. Okay, I still don't match any of our answers, though. So Andrew, what else do I need to do? Okay, split the integral, so like this. Okay, then 7.5 minus 7.3. This will be 2 times the integral from 3 to 5 of g of x minus 35 minus 21. So that's 2 times the integral from 3 to 5 of g of x dx. Why do I have a negative when everything else has a positive? I just didn't copy down the line correctly. Sorry, all of these are positives. So plus 35 minus 21, so that's plus 14. So this one matches matches B. Okay, any questions on 82? Okay. Rion, I think we're on, let's see, Kyle did 81. So, over to Eric. The Taylor series for the natural log is given here. I want to let f be the function given as the sum of the first 3 non-zero terms of this series. And I want to know the maximum value of ln x minus f of x. What do we need to do first?
Write the equation.
Okay, so we need to write the first 3 non-zero terms of the series. So what's my first term for this Taylor series that they've given for us?
Negative, no, 0.
So we need to plug in n equals 1 into this series and tell me what the first term would look like. So we should get an equation for the general form and be able to plug in any x value we want.
1 times x minus 1. So x minus 1.
Okay, that's term 1. Term 2?
Negative x minus 1 square over 2.
That's good. And term 3?
Plus x minus 1 cubed power 3.
Okay, so that's our f of x. I want to know what the maximum value of the difference would be for any x value between 0.3 and 1.7. So I think we can take this and graph it to see what's happening on that interval. So let me go ahead and do that first. So I'm going to graph the natural log of x. And I'm going to subtract our series that we just created. And we'll turn these other ones off. Okay, so top function minus bottom function. I'm going to graph these two, and what I'm going to look for, if I'm trying to find a maximum value, ideally, I'm going to look for any point where the slope is changing from positive to negative. I want my x values to be between 0.3 and 1.7, so I'm going to change my window to be somewhere around there. 0.3 to 1.7. And my maximum values are all below 0.53. And so I'm going to change these y values to be from 0 to 0.6 maybe. And we should be able to see what's going on here, I think. So let's graph that. Okay, I don't see anything. So points. X values 0.3 to 1.7. You're super close when we get in there. Oops. Let's calculate a maximum. There we go. Left bound 0. Oh, I started at 0.3. Left bound 0.3. Right bound 1.7. That's not good. Okay, we didn't match any of our options. Oh, this is an absolute value. I missed that. Okay, so I need to put these in an absolute value sign. So I'm hitting second insert so I don't overwrite. This is math numbers absolute value. Check the absolute value of y1 minus y2. We'll try that again. Okay, general shape of this, it looks like we're concave up in the entire thing. If that's true, then my maximum is going to be our start point, but let's give it a shot. Calculate a maximum from 0.3 to 1.7. I'll guess in the middle and we'll see what happens. Okay, our maximum is the start point at 0.3. And lots of calculator stuff going on there, but any questions on what we did for 83? All right. 84. I'm looking for what values of x would this series converge, and we're on Kyle next.
Mr. Brendan,
Yes.
isn't 83 we get the y value?
Oh, oops. I would have gotten that wrong. Is the x value. They're asking for maximum value. That is the y value. 1.45. 1.45. Okay, I'm going to check a key really quick on my other screen. This is C. Okay. Thank you. Kyle, I want to know which values would this series converge? What type of test do you think we need?
I used I think the ratio test. I think that's what I think.
Okay, ratio
So I
test.
used-
So, with the ratio test, this is x plus 2 to the n plus 1 over root n plus 1. And I'm going to divide by my original function, so that's x plus 2 raised to the n and then root n. And we'll take the limit as n approaches infinity and see when this is less than 1. So what, if anything, can cancel?
X plus 2 to the power of n.
All right. So that leaves me with limit as n approaches infinity of the absolute value of, I've got this root n over root n plus 1. And I'm going to multiply by x plus 2. And this needs to be less than 1. So this whole part on the left, root n over root n plus 1, what's the limit as n approaches infinity?
It's just going to be x plus 2.
Okay, that left part's 1, so that leaves me with x plus 2. So I've got x plus 2 is less than 1. Therefore, x plus 2 must be between negative 1 and 1. So what does x need to be between?
Negative 3 and 1. Negative 1.
Okay, negative 3 and... negative 3 and negative 1? I think I've gone a little bit too far over there. Can't hit that without hitting the side. There we go. Which is B. Okay, for...
Mr. Brandon?
Yes.
Will it be A, though? Because it's... Or is it greater than equal?
I see. So let's go ahead and test these through. So at x equals negative 3, what's going to happen when I plug in?
If x equals negative 3 plus...
Okay, so if x
Oh,
is
and
negative
then
3, I get this. Will this converge or diverge?
Converge.
Okay, this one converges by the AST. So this will be less than or equal to. If x equals negative 1, then this will be 1 raised to the n power over root n. Will that converge or diverge?
Diverge.
Diverges.
Okay.
Okay. Diverges. Converges. So this will be B.
Okay, got it. Thank you.
Over to 85. Trapezoidal approximations. I think we can type this. Okay, so Andrew, If I want a trapezoidal approximation of our integral from 2 to 8 using the intervals in the table, what would our area have to be equal to? If it's easier, you can give me one trapezoid at a time instead of giving me all at once. It's up to you. Okay. Uh, 10. Hold on. That last one should be 30 plus 10, I believe. I'm just reading the average there. But otherwise correct. So base is 3. Average would be 30 plus 10 over 2. Okay, that was perfect. So 1/2 to 70 and 1/2 160. If I add all of that together, what do I get? $160, perfect. Okay, back to Eric. We've got the base of our solid is this region in the first quadrant bounded by the x-axis, y-axis, and our line. Cross sections perpendicular to this solid, perpendicular to the x-axis are semicircles. I want to know what is the volume. Cross sections perpendicular to the x-axis are semicircles. So that's going to look something like this. Cross sections that are perpendicular to the x-axis are semicircles. So popping out of the page like this. Okay, I want to know what the volume of the solid would be. So in order to find the volume of the solid, I need a cross-sectional area, and then I want to multiply times our depth. So first, I need an equation for the cross-sectional area that we have here in green. So if this is a semicircle, what's the area of the green region?
Two pi r squared over 2.
Okay, it should be pi r squared over 2. That means I need to know what my radius is. So my radius here in red should be equal to... what is this red distance? You can give it to me in terms of x or y if you want.
Is it y?
It's just y. Okay, so my r is y. And our y is based on this equation. So if x plus 2y equals 8, then what will y be equal to?
8 minus x over 2.
Perfect. So that should be my radius then. Okay, then lastly, I should have an infinitely small value here for how wide our cross-section is. How wide will our cross-section be?
dx.
Dx. So that's our infinitesimal for x. Alright, so let's plug this in. We'll get our area equation, then I'm going to jump over to Kyle for volume. Actually, let me jump over now. So, Kyle, what's our area?
Oh, it's 8 minus pi r. No. Pi times 8 minus x over 2 squared over 2.
Okay. Then for our volume, which will be what happens when we stack this together. Andrew, what do I need to do in order to get our volume? We've got an area now. How can I get the volume? You can tell me the process if you don't want to give me an equation, or give me an equation if that's easier for you. Right now I've got the area shown in green of the two-dimensional cross-sectional area of the volume that we want to create. So what do I need to do to our area in order to get the volume of the shape? I'll zoom out so you can read too. Okay, so our volume is going to be equal to our area times our change in x from our start point to end point of our x value, which is from 0 to 8. So that's pi over 2 times the integral from 0 to 8. I'm just going to copy our area equation. So that's 8 minus x squared over 2. I could probably pull that out just because it's constant, and that would give us... Oh, I guess we don't need to. I'm just getting an answer. Well, pi eighths times the integral from 0 to 8 of 8 minus x squared. Okay, so I'm going to go ahead and plug this in. Pi over 8 times the integral from 0 to 8 of 8 minus x squared. In terms of x is 67.02. Okay, I don't match, so I've got to figure out what we did wrong. I didn't half our radius. That's why. Okay. My radius is not equal to my y value, actually, as my radius is going to be half that distance. So I need to go back. My r should be y over 2, which would make this half of what we had originally. Changing this to over 4. Over 16 over 32. Okay, originally that was over 2. If I divide this by 16... Just going to reintegrate. $16.755. Alright, sorry about that. Okay, we are 1 minute over time, so I'm going to stop at that one. But any questions on 86?
Nope.
Alright. Thank you guys so much for coming. I'll have one more session tomorrow. Hopefully, we'll finish off the rest of this. We've only got 5 left, I think. So if we finish off everything completely, I'll open up for any questions or topics you guys want to talk about. And if nobody's got anything, then we'll probably end really early tomorrow if it's just the BC students.
Okay. Bye. Thank
Alright,
you.
goodbye, thank you.
Thank you.